Welcome to MEGN 301 Injection Molder Final Project video, presented by Fahrenheit 347 Team E3. Plastic pollution has become a major environmental challenge and has not been helped by the growing use of 3D prints, with many of those 3D prints being thrown away because of misprints or they just made little knickknacks on their desk that they got tired of. Injection molding, however, has been around since 1872 and has been proven useful in using recycled ABS plastic scraps and repurposing them for making something new and useful. Our objectives when making the injection molder were to have an adjustable temperature ranging from 177 to 240 degrees Celsius to make sure that we could properly melt the plastic. We had to make sure that the injection molder could exert 200 psi into the mold so that the mold would completely fill. But we also need to make sure that the end of the lever arm and the stand itself did not deform in any way, whether by breaking or bending, when 160 pounds of force was exerted. For the temperature device, we also found that it needed a 120 volt wall power source. We also wanted to make sure that the controls would be user-friendly, so someone did not need to have to download some foreign program onto their computer in order to change the temperature or anything like that. And because we were thinking that a hobbyist would be the most likely person to use this, we wanted to make it compact and so it didn't take up too much space and also be able to transport it by one person. We also wanted to make sure that there was a solid interface between the mold and the heating tube. Overall, our injection molder works. As you can see here, as we're pushing down, the heating tube has done its job melting the plastic, and the plunger and lever arm are doing its job exerting the force needed to push the melted plastic out of that heating tube. And the two pictures on the end are more up-close pictures of what our stand looks like when not in use. You can see the brackets there connecting the heating tube and the lever arm, as well as the back of the lever arm to the back portion of the bracket, making sure that it would have full range of motion while optimizing all the force to go downward into the heating tube. In the middle picture here is our PID that controlled our heating bands, which can be seen slightly on the first picture. And this would make for an easy interface for the user, as the two up and down arrows control what the temp is at. The sideways arrow controls whether you are in degrees or Celsius, and the red button will determine what temperature you set it at. And to turn on this device, all you would need to do is plug it into an outlet. Comparison of our prototype to design metrics. So for the design metrics, we really wanted to focus on adjustable temp, exerts 200 psi into the mold, can withstand 160 lbf, and has a solid interface between the mold and the heating tube. We were able to meet the adjustable temperature and the psi and the lbf, but we were unable to meet the solid interface between mold and heating tube, which goes into our future work, where one of our bigger things that we would like to continue working on would make a better mounting system for the mold for ease of use. This can be interpreted into a couple different ways, whether that be making it so that the heating tube is more easily adjusted, or making a specific stand piece for the mold that can be lowered or raised so that at all times the heating tube and mold are pressed up against each other flush. Another thing we would like to do would make a mounting for the controller and relay frame, basically making a box that would be connected to the frame, having all the wires in there, and then having the control part of the PID flush with that wall so that the user could easily access that. Something else we wanted to do is possibly change the geometry of the back part of our bracket so that the heating tube can be removed from the plunger can be removed from the heating tube more easily. Thank you for watching.